I am the developer of Amiko Pay, and later in this presentation I will explain what Amiko Pay is, and it is a method for performing off-blockchain transactions. So before I explain why Amiko Pay is the right way to perform off-blockchain transactions, first a few words about why they are necessary in the first place. So this quote, "The price of freedom is eternal vigilance." It's often attributed to Thomas Jefferson, incorrectly I believe, but there's still a core of truth in it. But if you look at it as an economical equation, then you can say that when vigilance becomes cheaper and more accessible, then we can afford more freedom. And that is what I hope to achieve with Amiko Pay. Now, if you look at the blockchain, which is the core data structure of Bitcoin, it's basically a log of, that is built with all the transactions that happened. And when new transactions happen, they are added to the blockchain, and the blockchain gets distributed across the Bitcoin users. Because there is no central party who performs all the checks about the correctness of transactions, the Bitcoin users do that themselves. They do not assign a single person to perform the checks, but everybody performs the checks. And this is a nice way to decentralize things, but it is also an expensive way of doing things. If the number of users grows, then the number of transactions grows, and the number of checks that people need to perform and the amount of storage that people need grows even faster than that. So this is if we really want something like Bitcoin to become successful in a large population, this is not a feasible model. Still, the blockchain is a really useful way to reach consensus about certain things, but I think it is necessary that most transactions stay outside the blockchain. That we only keep those things in the blockchain that for which it is really necessary to put them in the blockchain. So therefore, we need to find a way to make transactions secure, even though they stay outside the blockchain. And that is what Amiko Pay will do. I will skip a couple of slides to save time. Amiko Pay creates a network of arbitrary shape, so anybody can choose to connect to anybody he likes, just like the internet, actually. And payments are routed over that network. So if two people in the network want to perform a transaction, they find a route over the network with several intermediaries, and the transaction goes from the paying party to the next, and then to the next, and so on until it is received. And the trick is, of course, to do this in a secure way. This might look a bit like an interbanking network, like banks also have their way of, if you perform a payment from one bank to another, there is some channel over which that is performed. But the way you need to trust each other in a system like this. And the way how trust is achieved between banks is through licensing and regulation and auditing. And that has its own disadvantages, and the way how it works in Amiko Pay is fundamentally different. In Amiko Pay, it is achieved through cryptographically linking the transaction to things that can be enforced in the blockchain if necessary. So normally a transaction does not have to be enforced in the blockchain, but if something goes wrong, we will use the blockchain to enforce it. First, I will tell you how it is performed on how security is achieved on a single link, and then I will explain how the synchronized with each other. So for a single link, I will skip all the details, but for a single link, a microtransaction channel is used, and it is a relatively unknown feature of Bitcoin. But in a microtransaction channel, two parties who do not trust each other, they can create a channel where they perform transactions between each other. And the transactions do not need to end up in the blockchain to be secure. So in this instance, the channel is created by Alice, who deposits 1 Bitcoin into the channel. And at that point, Alice, the channel guarantees to Alice that Alice can get her Bitcoin back if she wants. Now, if Alice performs a micro payment over the channel, in this case 0.4 Bitcoin, then the 1 Bitcoin gets split between Alice and Bob. And the channel works in such a way that Alice is guaranteed to be able to access the 0.6 remaining Bitcoins, and Bob is guaranteed to be able to access the 0.4 Bitcoins. So they do not need to trust each other. But by the way how the channel works, they can be certain that they can access the amounts that they deserve. And this is used in Amiko Pay on every single link in the network. Now, if you perform a transaction, you want to, of course, you want to be sure that if the transaction is performed on one link, that it also gets performed on another link. Because if an intermediary node receives funds from one side but doesn't send them to the next, he could steal these funds. And also, if he sends them but he doesn't receive them, he loses money. So that's are the sort of things you don't want to happen. You want either all of them to commit or none of them to commit to the payment. And first, to accomplish this, first I make a modified version of the micropayment channel, where payment is split into 2 different phases. First, a lock, and the lock locks the transaction amount so that none of the parties can access it. And then a commit phase, where the transaction amount is assigned to the new party. And of course, there's also a rollback variation where the locked amount is assigned back to the original owner, just in case the transaction goes wrong. Now, in order to synchronize these channels, first the receiving end of the transaction creates a token, which is a random number. It must be securely random in the sense that no one else can guess the token. And he calculates the secure hash value of the token. And the secure hash value is distributed so that everybody can recognize the token when it arrives. Next, when everybody has the hash value, the transaction gets locked. And then it gets committed. And a commit is requested to a node by sending the token to that node. When a node receives the token, he knows that the transaction will commit. And in fact, this direction of sending the token is the most important one, because these are on the receiving side of the transaction. So on this side, the nodes have an interest in having the transaction committed. So token is distributed, and then commit is performed. And I'm not sure if this is necessary, but there's also a way to roll back a transaction that is sent by the receiving end of the transaction. And basically, a rollback is a message that by rolling back, you say, I will never ever release the token, because it would be stupid to release the token, because rollback guarantees that you will never receive your money, and with the token, you say the transaction is okay, and that would be stupid if you are on the receiver side of the...
Which moments in the process the rollback is executed?
I'm not certain that rollback is necessary, is a necessary feature of the transaction at this point, but if a lock is performed and the, before the token is sent around.
So when between tokens and between the hash sent?
No, the hash is sent first,
then
the transaction is locked.
After
that you can roll back.
Okay.
Yeah, but it is before you send away the token. Because as soon as you send the token around in the world. Yes. Now the major problem is what if some link is broken because of a communication failure, or maybe because a node doesn't want to cooperate. And the way to deal with this, in essence, is we look at the blockchain. If the commit is not received in time by the receiving end of the transaction, then the receiving end publishes the token in a transaction on the blockchain. And all the other nodes can see that, and they see that, and by seeing that token, they know that the transaction is committed. Now, if that is, if the token is not present in a certain range of blocks, then they conclude that the transaction is rolled back. And in this case, you see that on some places the commit has already happened, and because the token was not present, some of the nodes will roll back. This is an undesirable situation, because the node here will receive money and doesn't have to send it, so it's good for this node. But for this node, in this case the merchant, it's not good, because he already allowed the buyer to walk away with its goods or services, but he does not receive his funds on this link. So this is an undesirable situation, but luckily the losing party in the situation can prevent it exactly by publishing the token on the blockchain. And the order of the sequence is such that the losing end of a disagreement is always capable of preventing the loss. And but these cases are only necessary in the case that the transaction fails at a certain point. So that should be a very small percentage of transactions, but it is still an important aspect of the system, because if you have a guarantee that that communication failure will not lead to a failure of the system as a whole, then it is no longer an advantage of nodes to deliberately fail.
So, question in this scenario, you mark the red one as broken, no? Imagine that node is destroyed, you close down, and then the person at the end wants to get paid, so it publishes the token in the blockchain.
This one publishes the token, yes.
And then how can he ensure that the missing party is going to transmit money?
It is, well, in the first place, it is a way to reach agreement between two neighboring parties that there has to be a commit. But as you see in the microtransaction channel, the conflict is about this part, the locked amount. And this is a bit of a limitation in Bitcoin, that I cannot put these conditions in a Bitcoin script. So right now, the script I use for this part is 2 of 2 multi-signature address. So it can only be accessed if they agree who owns it. Of course, one of them can be mean to the other one and say, well, okay, you are right, but I'm not going to release it anyway. So there is an attack mode between direct neighbors for hijacking a certain amount of money. But it is a limited attack mode because they can only hijack the amount for a single transaction, not the entire channel. Because these are still safe, these parts. And it can only happen between direct neighbors. And typically it can only happen a single time because after that time you no longer trust the direct neighbor. Now, there is something else. These are the commit and rollback conditions for a link. The first ones are simple. If a commit message was sent, then it is committed. If a rollback message was sent, it is rolled back. These are enforced by the microtransaction channel. And the other one is about whether that token is published in the blockchain or not. And this can not yet be enforced with Bitcoin scripts, but in theory, this knowledge is known by miners. So you could make extension, if you change Bitcoin or make an altcoin, you could make an extension of the Bitcoin scripting language, which includes this kind of functionality. And then it would be completely safe, even with neighbors that have no trust in each other.
Did you try to commit it to Bitcoin?
This change. No, I think it needs a bit more thought about the further consequences for Bitcoin, because you let the condition of one transaction depend on a completely other transaction, and it could have impact on blockchain pruning, for instance. So I think that needs some thought, and for now I will continue developing Amiko Pay to see whether there are other problems in it. I think this is a minor problem in Amiko Pay. It might even be the case that we can live with this problem. But if there are no other problems, this could very well be an argument for including this functionality in Bitcoin software. And if it is not included in the Bitcoin software, it could be included in an altcoin, or even if sidechains are implemented, we could make a sidechain that has this functionality. I believe it is really important to have off-blockchain transactions. They make Bitcoin more scalable, but these off-blockchain transactions, they do not have to wait for confirmations. So in the normal case, in the first case, so to say, they are really fast. There's no limit on how fast they can be.
Only if you need settlement in between, then it goes to blockchain and you need time to get it.
Exactly. So if something, but even then, there can be parties. If a party in this link already has 2 commits on both sides, he no longer has to worry about the transaction. So even if somewhere else in the chain something goes wrong, he does not have to wait for the longer settlement procedure. For instance, let's say in this case, no. In this case, the buyer already has 2 commits on both sides. So the buyer doesn't really worry about it anymore, because whatever happens on the blockchain no longer has an influence on his own links. Yeah. And if this link would have succeeded and the problem is only somewhere in the middle, then the seller also no longer has to worry about the transaction, because he already has 2 commits. So then, if you have a point of sale situation, the seller says, okay, you can leave the shop with your goods. It's immediately settled for these people. So, development of this. In 2011, I knew about the Ripple system, which inspired me to have this network-like shape of the network, the internet-like shape of the network. And I knew about Bitcoin, which in my view was safer than having debts between direct neighbors and didn't require the trust. So I combined those, and in the beginning of 2013 I ended up with these ideas and I started developing a prototype. Right now, the prototype has some functionality. You can create links, you can create payment channels between people. There is routing, although it is very primitive. And I already created the first Amiko Pay transactions through sort of a micro payment channel. And you can really see, you can perform a couple of transactions, and then at the end you get a single Bitcoin on blockchain transactions to get your Bitcoins back. So it can really save on transaction fees, and it is a lot faster. And I believe this is important for the future of Bitcoin. This is a screenshot. It doesn't really work here, but in the background you have the Bitcoin core software, and on the foreground I have a terminal window where the Amiko software is running, and I request a payment. I give it how to pay it. In this case I'm paying to myself, and then immediately says payment is committed.
Is the transaction fee lower because you are actually not really using the blockchain?
Yes.
Okay. So in other words, you are circumventing the miners or the middleman in that sense, and that way not paying the transaction fee, at least for the blockchain.
Yes, you are circumventing the miner fees.
Okay.
But in my view, development progress has been a bit slow. First, it was idea limited. I had to develop all the ideas how to make this system, but now it is actually development speed limited. I only have maybe, well, a little bit